let's try this, and then if there's time, we'll go to another advent of code. Quest 3, Part 1. The top knights of the Golden Duck Order are famous for not just their skills in battle, but also for their talent in building. They lead all royal building projects, making sure their designs are both impressive and eco-friendly. Their buildings are praised for blending in with nature, and they are especially valued for construction methods that protect the environment during the building process. All right, so what are we doing? Removing blocks. Oh, we're digging a hole. Okay. So let's get our notes here. And take a look at it. Okay, so it's just this little plot of land. And it looks like we're digging out. Here's a highlighted text. The height difference between adjacent areas both side to side and top to bottom must never be more than 1 unit. Of course, mining is only allowed in the areas marked by the alchemist with a simple hash. There's a little plus sign on the... That's cute. Wonder what that means. If I click, does it do anything? No. It just has a plus sign. Oh, I see. I triple clicked and it copied it to my... Okay. Very cute. So it looks like what we do is we look up, down, left, right, and if there's a spot, if there's a hash in all 4 directions, then we can dig it out. In the first layer, the entire marked area can be safely dug out. This allows for removal of 25 blocks. Okay, so the entire area gets marked. Okay, and then we have to look up, down, left, right to see if we can dig those. And then we dig out those as well. In total, the maximum number of earth blocks that can be removed while keeping the slope at a safe degree is 35. How many earth blocks can be safely removed from your map? All right, let's try it out. So this is pretty straightforward, right? We're going to first go into cargo. Oh, this is input for day 3. We're going to go into our cargo toml and we're going to say workspace, no, AOC lib workspace equals true. And that way we have our AOC lib read lines, input, whatever it's called. It's called that. So this is an array, a vector of strings. It should have all these entries. So we can print those out real quick. Println lines. Yep. So we have all of these guys. And now what we'll do is we'll add up all of the hashes, right? That'll be our first removal. And then we'll generate a new map or a new set of values from that has entries up, down, and left and right. So let's do this first. Let's say let map is equal to, actually, we're going to need it for parts 2 and 3, right? So struct map. Earth is a hash map. We only care about if there's something there. Oops. Nope. Other way around. So we'll do that. Map new lines. Impl map. New, and then this is just going to be lines, which is going to be string, which is going to return self. And we're going to go through each line for a row in lines. Iter enumerate. Or call in. Oh, this is a row line. I should also make this a thing. I got to add a grid inline chars enumerate, because I've written this bunch of code I don't know how many times now. If ch is equal to dot hash, then we're going to say self earth let mod earth equals hash set new. Earth is insert row as I64, call as I64, and then we're going to return self earth. I'm missing something. I'm missing that. There. So now we should be able to print out the map. And just see all the points where a hash is. So row 7, column 10. 0, 1, 2. Oh, no, in my input. Input everybody. Oh, there we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, 7. 1, 2, 3, 4, 5, 6, 7. So it's basically right here. Okay, so I think that's working. And given this, now all we need to do is count up the entries and then do a step. And the step is just going to retain entries in the hash set if the hash set has up, down, left, right. And we just sum those all up. So we can say loop let count equals map dot len if count is greater than 0. And we can have a total. Total plus equals count. If count is equal to 0, then break. And then we're going to print out part 1 equals total. How's that? If it's not 0, field earth is never read. Yeah. It's map earth len. Okay. So we add the count in, and now we'll say map step. And that'll take 1 step. So we're going to loop over all of the entries and create a new earth. Self earth iter map xy row call, and then we'll take a peek in side and we'll see if it's something, and then we can say collect hash set of I64 like that, and this will be this. Doesn't like something. Syntax or expected expression. We want to filter, right? I'll just say none for now. Is that going to work? And then say self earth equals new earth. Map needs to be mutable. Yeah, Okay, I think that's working because this is going to collect it into, yeah, hash set of that. Okay, so now what we do is we just check up, down, left, right. If self earth contains row -1 call end, and we can do that for all 4 directions. Row +1 call, row call -1, and row call +1. Then we'll say sum, row call, else, none. Do I have to do this as well? Oh, I'm missing this. And I'm also missing all of these guys here. There. Oh, these have to be starred. Okay, so if I do this, oh, it has to be this time. Okay, so then we put stars everywhere. And now we have a problem here on line 38. New Earth is never mutable. Okay, we never need to mutate it. I have 134 as the answer. We can print out each. Does it make sense to? Or let's just trust that we got it right. Let's trust that we got it right and see what happens. 134. I'm on a quacking roll. How about that? 588. I wonder what your place has to be in order to start getting points. All right, so that was part 1. That's not bad. Git status, git add, ... Can I do that? Git status. I can. Cargo lock. What changed there? Oh, it's adding each package. Interesting. Okay. Git commit -m day 2024 day 3 part 1. There we go. Part 2, finishing the task quickly allows you to move to the next pair of this challenge. This time the map is much bigger and more complex. The task is the same, but the larger size requires more accuracy. More accuracy? What does that mean? Will your intelligent thinking and developed instincts be enough again? Let's find out. Let's download that one. Part 2. Okay, so it's just a bigger map. It has a hole in the middle, but that shouldn't matter. Should we, so I did this like this. Maybe what we do is create a function on the map which does this work for me. So let's refactor that. So fn total self, right? And that way we can just pass this in and not have to do it multiple times. And then just return total here. So it should still be 134. If I say map total. Doesn't like that. Oh, because this needs to return usize. Still doesn't like it. Oh, because this should be self. There. So, okay, so that's still 134. So now all we need to do is do it for the next part. $25.39. All right. I'm quacking unstoppable. How about that? 582. What was the other one? Was the other one 588? I can't remember now. So we're getting there. We're getting there. So what's the next one going to be? There's got to be some twist, right? The final map of the challenge concerns the royal lands. The rules largely remain the same, but the map includes several separate areas. To improve the comfort of the pawns created at the end of this process, the king requires that the rule about gradual drop in slope also applies to blocks that are diagonally adjacent. Got it. All right. So let's download this. It's only 433 bytes. Why does that seem wrong? Okay. Oh, I was looking at the first one. I was looking at part one. Part one is 4.3. Okay, so this is 7.3K, so it's bigger. Okay, got it. But now we have to do diagonal. So the step changes. So how would we do this? We'd want a way of telling the step whether to pay attention to diagonals. So we can just do that with a Boolean, I think. So it's and, not diagonals, or we do the diagonals. So it's row -1, col -1, row +1, col +1. And then we flip it around. Row +1 and then row -1. And then we do that for that. And I need this maybe? And this? There's still something wrong here. Syntax error. Okay, well, first of all, this diagonals is false. It's going to be diagonals. But I got something wrong here. Oh, I got a plus there without the 1. Got it. And now we have to say false, false. And here, true. Right? 10.3.32. Yeah. Did I do this right though? This is lower left. Oh, okay. Yeah, if we do row -1, if that's upper left, lower right, lower left, and upper right. Yeah. Okay, I think it's right. Let's see what happens. I quacked it out of the park. How about that? 559. Yeah, we're getting better. Git status. Git commit -am 2024 day 3 part. Oh, I never committed part 2, did I?